Okay, let's talk about page 8. Here's a proof for us that has it's related to one of our earlier constructions. And you may not remember this term, but it's a perpendicular bisector, which is kind of a big deal. All right, the perpendicular bisector, just to recall, remember, we had a segment here and we put our compass on each end and we threw an arc up here and down there and over here and down there. And we did the construction and we drew that line in there. And there was a couple of things that happened. It was perpendicular, which meant it made a right angle, and then it bisected. So remember, there were two words, and so that means it cut this into two equal parts. So this was the construction, and then this is what's happening. And so what it's saying is prove that point H anywhere along this perpendicular bisector, point H is equidistant to the endpoints of U and V. We can prove it because remember, I think I did this for you one time. You can pick any point along here, and if I measure to that end, I measure to this end over here, they will be the same distance. Or if I pick one up here, if I measure those distances from there to there, they will be the same anywhere along that perpendicular bisector. So prove that they are. Well, as you might have guessed, we're going to prove it using congruent triangles. Okay, and it says that HT is the perpendicular, that's perpendicular bisector of UV. All right, so a couple of things that are happening, we should put those markings on there. So if I did this, if I knew that it was meeting this at 90 degrees, and I knew that it was bisecting, it was cutting this into two equal parts, can we prove that this triangle over here is congruent to this triangle right here? We should be able to do that. All right, so let's see if we can write down the steps to get that done. Here's a given. So I'm going to say that this angle over here, angle UPH, and angle VPH are right angles. And the reason I'm doing that, the reason I'm saying that is because that's the definition of perpendicular. Can I use an upside down T for that? We should be able to do that. Perpendicular. It means right angles. Okay. And then we're going to steal something that Euclid said. We're going to say angle, therefore angle UPH is congruent to angle VPH because all right angles are congruent. All right, so we just have to have a statement. I know you can see that they will be, but we have to state it out that they are congruent. All right. We can also say that UP is congruent to VP because that's the definition of or the result of bisector. Remember, when you have a bisector, you get two congruent parts. We also ought to be able to say that HP is congruent to itself because of reflexive property. And then we should be able to say that the triangle on the left, UPH, is congruent to triangle VPH. And I think it's obvious. The markings tell me it's side angle side. All right, now here's the new thing, okay? We're not only proving that triangles are congruent. We did that. Remember, what I'm trying to show is that this piece right here is the same distance as that one. That's not necessarily proving the triangles are congruent. Now, I'm going to use triangles congruent to do this. But here's the argument. If this triangle over here on the left is congruent to this one on the right, and I know I've got these congruent parts right here, side angle side, but by definition of congruence, aren't the other parts congruent? Yeah, that was the whole premise of this anyway, that if I've got some of the parts congruent, then I know the other parts have to be congruent as well. So as a result of having congruent triangles, I've got that established. I should be able to now say that UH must be congruent to VH. And the reason is, and I'm going to say it right here, UH congruent to VH because these are corresponding parts. Let's just write out this sentence right here. Corresponding parts of congruent triangles are congruent. All right. This sentence right here, you are going to use a lot because we don't always just end our proof with step 6. Sometimes we just add that one little step down there at the bottom and say that all the corresponding parts are congruent when the triangles are congruent. Done. You should be able to do that and use that over here on page 9. These are going to be a little bit of a challenge for you, but I've filled in some of the blanks on this one. This one I left you on your own, but I think you can do it. But just so you know, if you see that it says we're going to prove this, that means somewhere along here we're going to prove the triangles are congruent, and then down here below it, you're going to use that same reason. That's going to be after we get the triangles are congruent, we can say the parts are congruent. Same thing right here. Since I'm going to prove these parts are congruent, I'm going to have to prove the triangles are congruent first. And I'm going to leave this one more open for you to try.